All right. For these first couple problems, we're going to go through it here in this tutorial. We're going to be using the equation from the slideshow, solving for acceleration, and we need to know the final velocity, the initial velocity, and then how long it took to go from the initial to the final velocity. So in this scenario, let's just say a car is driving at 20 meters per second and it's going to accelerate. Okay, the velocity is going to change up to 40 meters per second. And again, with a car, we don't usually talk about it in terms of meters per second, but you could think of it as miles per hour. Okay, but this is a velocity. It's similar to a speed. Okay, it's got a speed and direction. Okay, so velocity is 20 when it starts out, and then it ends at 40. And I'm wondering how long. Uh, or the rate of acceleration. Okay, I know how long. It took 5 seconds. So uh, if I go in to show my work, the first thing I'm going to type, and this is going to look a little weird kind of on the computer, but our equation is acceleration equals v, oh, don't do that. Okay, I apologize. I was trying to do a subscript. Basically, vf minus vi. I'll put that in parentheses because that really is the top of the equation, or all together before you divide by time. And so time. Okay, I'll write it like that. So again, this is your final velocity minus your initial velocity. So you got to pay close attention. Don't do your initial velocity first. So if I rewrite this though with the numbers in there, it would be 40. Okay, and for the sake of space, I'll leave off the units, but don't forget the units are there. 40 minus 20. Okay, again, I took that from our final velocity and our initial velocity. Okay, then I'm going to divide that by time, which it took 5 seconds. So if I put this into my calculator and kind of break that down real quick, I would type it into my calculator as 20 divided by 5. And the reason I got 20 is because I did 40 minus 20 actually gives you 20. So 20 divided by 5 equals 4. So our rate of acceleration would be 4. Now, it's important to remember this would be 20 meters per second divided by seconds. Okay, because again, these are our velocity and this is our time. So the units for acceleration in this scenario would be meters per second per second. So it actually looks like that. And again, a way to think about this is that it is accelerating. And in this situation, it's a positive acceleration. It's increasing in speed. Positive acceleration of 4 meters per second every single second. Okay, so after 1 second of hitting the gas, if you will, after 1 second of accelerating, it is going to be going 4 meters per second faster than when it started. And after 2 seconds, it's going to be going an additional 4. Okay, so that would be 8 meters per second. So again, 4 meters per second every single second that it's accelerating. So that would be our answer for A. And again, when you go to type these into the formative, if you type it in like that, it should be marked as correct and auto-graded. Okay, one more practice problem. As I scroll down here, okay, using the same scenario, I've got A equals VF minus VI. And I should put parentheses around that. Divided by time. So in this scenario, I've got a final velocity, if I look over here, of 100. Woo! Going fast. Okay, and the initial velocity is 0. And so this is going to be pretty common actually. If you have initial velocity of 0, that means you have an object or a situation where, let's say, a car again is sitting still. Okay, it's parked. It's not moving. So and then we're trying to figure out the rate of acceleration to get to 100 meters per second, which is pretty fast. So and then we know in this situation the time, it took 20 seconds. So again, if I just kind of going through each step, this would be 100 meters per second. Maybe I'll put that in parentheses like that. Divided by 20 seconds. I put that into the calculator. Okay, I believe it should be 5. So 100 divided by 20, yes, equals 5 meters per second would be the rate of acceleration. So that again would be your answer, and you can record it just like that. Okay, that's the end of this tutorial. And again, we are using this equation here. A equals your final velocity minus your initial velocity over time.